Hi, my name is Dulma. I am a software engineer at Facebook here in the London office. And I work on static analysis, so that's what I'm going to be talking about. So we developed a tool called Infer that was developed by Facebook, but it's also open source. It's been for about 2 years. And it helps find bugs in various languages, in particular for mobile apps. So bugs in mobile apps are particularly bad because they crash the whole app, and it's difficult to update the app to a new version. The user has to do it. So at Facebook, that's particularly important to make sure that there are not that many bugs that make it into the app. So especially because of this very fast deployment model that Facebook has. So code gets sent to review and then committed, and very soon after it is deployed, by the way. And so in the case of the apps, then it gets deployed soon, but the user has to actually update it. So the way that Facebook keeps with this fast release cycle without making sure not to insert too many bugs in the apps is having a very strong CI that has many tools like testing, unit testing, performance testing, end-to-end testing, and also static analysis. That's what I'm going to talk about. So static analysis is basically some tool that takes the source code of some program and delivers some information about the program. There could be potential bugs, or in case of linters, it could be not necessarily bugs, but like code style issues that could be improved, things like that. So there are various types of static analysis. The more syntactic ones are like linters, and the more deep analysis that try to figure out the semantic of the program. And so Infer has a bit of both. So the interprocedural part of Infer is novel in the sense that it doesn't take that long as many of the static analyzers are there. So normally they would run on whole projects, take many hours, and produce the list of bugs. And Infer, well, it doesn't need any annotations in general, even though it takes annotations into account. It finds pre- and post conditions automatically about the methods, about the memory usage of some methods. And it's compositional, which makes it incremental and fast. So it is available for various languages, I'm going to say. I'm going to talk a bit more examples about what we can do for iOS apps, but we can also do many things for Android apps. So it analyzes what needs to be compiled. So basically it depends. The time it takes, it depends in how much needs to be recompiled. So it can be a few seconds, depending on that. So the interprocedural part of Infer, as I said before, finds deeper bugs that can span multiple files and over a stack of various calls, so like a null pointer exception. And then there are linters, there are syntactic checks, and they are local to one procedure or one file. And so I'm going to speak later that we also have a framework for linters inside Infer. So we have various types of bugs that we find, like not reference, that is available for Android and iOS, and also C++. Memory leaks, it's only for iOS. Resource leaks for Android. And C as well. So these are the languages supported at the moment: C and C++, Objective-C and Java. So no Swift yet. And so this is how Infer is used in Facebook in the CI. So developer submits a code change to the CI system. That code change gets to some machine that runs Infer. Infer runs. So the code reviewers submit their comments. Fabricator is the tool where we do the code review. Infer also submits if it finds some bug. Then it looks like this. So it's like a comment in the web interface. So it's very easy to use. Developers don't need to do anything, it just appears there. And so if they find it's useful, then they can fix it and move on. So when all the code reviewers are happy and Infer is happy, then that code gets committed, and then the mob test, continuous test, and then it gets shipped to the app. So currently, Infer runs on thousands of code changes in Facebook mobile code bases, and also some backend systems. And so hundreds of potential bugs are reported and fixed by the Facebook developers. And the fix rate is about 50%. So basically, there is no push, and the developers don't have to listen to the Infer reports and fix them, because sometimes there are false positives. But then in a good number of cases, they do fix the issues, and they're useful issues. So now I'm going to show you a few examples of the kind of issues that Infer finds in some Objective-C code. So not reference. So this is an example where there's a property that is annotated with nullable. And then Infer can take that information into account, that there's an annotation of nullable. And so here we create a person, and then we take this property child, and we try to add it to some dictionary. And then Infer will say that this could be null, because, well, it doesn't know it's not null, and it's annotated. So we'll show you that. So another, so this is about an annotation, but it could also be that this variable child was, there is some path where it could be null in some method called somewhere else, and then it is called, and then it knows that it could be null, and it shows you that. And the reason why it shows it here in a trying to adding it to a dictionary is because that causes a crash. So that is something that is modeled inside the tool, that adding null to arrays or dictionaries in Objective-C causes a crash. So another thing is parameter not checked. So when you try to call a block in Objective-C that is null, that is also a crash. And so we have this check where you have a block as a parameter, and then we warn you that this, if you pass null there, then it could crash. And also it takes into account the annotation, so if you annotate it with non-null, then it won't crash. It won't show you anything, because then you know what you're doing. Something similar is for instance variables. So if you have an instance variable that is a block, you try to run it, and if it doesn't know any better, it will tell you it could be null. So be careful, if it's null, it will be a crash. But if you annotate it with non-null, again, it will take that into account. So memory leaks. So in general, we don't report memory leaks in like actual Objective-C objects, because that has automatic reference counting. But there's still this core foundation and all of these more C-style objects that are used that do need to be released. So we model that, and we would flag when you create some memory with one of these create functions that needs to be released. Like in this case, some font. We tell you there's a memory leak, the memory allocated to this call to city font create with name has not been released. So that is that part, and then there is also the linter framework that we have inside Infer as well. So we are working actually on a language for writing linters, because basically we're a small team and we have many requests for many checks, and we would like anybody to be able to write checks. And so our tool is written in OCaml, which is very good. We like it a lot, but many people don't know it and find it difficult to get into it. And so we are writing this language that is a domain-specific language for this purpose of writing simple checks. So it's for looking at the abstract syntax tree of a file and traversing this abstract syntax tree and finding some properties about it. So I'll give you some examples. So we have right now a few checks available that we have because developers at Facebook have been interested. Like if you access a property directly inside some function or method, and that property is atomic, then that makes it non-atomic. That's one. So a delegate property should not be strong in general. That pointer should not have the assign property. It should be strong or weak. When you allocate a registered observer, then it should also be unregistered before being deallocated. And we have recently developed a check for checking the availability of APIs. So that's something that I found quite interesting, that Apple has these annotations and it's available to know which constant or selector is available in a particular version, but there was no tool for checking that. And obviously people cannot be keeping track of all that in all the APIs that they called. And so we built a check. It's rather simple, and it has been very useful at Facebook because that causes actual crashes when you call an API that is not supporting the version you want. So I will show an example of that last check a bit later. So right now I wanted to show you how this linter language works. So let's have a look at this assign property check. So we have this simple example of an Objective-C class, my class, with a property that is a pointer to other class, and it has the attribute assign. So here is an abstract of the abstract syntax tree for this code. So you see there is Objective-C interface declaration with an Objective-C property declaration inside, and there you can see type and the attributes. So you can see that it's just a matter of going through that tree and finding the information you need to do the check. And so this is how the check looks like in AL. So you define a checker. You give a name, assign pointer warning, and then you say report when, and then you say when it's assigned property and its property pointer type, and that holds in the node Objective-C property declaration. So the parts, the when and the holds in node and all that is part of the language, and then the is assigned property and its property pointer type, these are predicates that we define inside OCaml. We have many predicates, and we're looking into adding many more so that there's a good library available, but one can also just add more. But that would be the one part when one needs to write OCaml. And so we're now in the process of making this language much more accessible and documenting it well. So there will be soon in our website much more information about how to use this language. It's about using predicates, connectors like AND and OR. It can hold in some particular node of the AST, and also it can do things like holds eventually She's like, go inside the tree and find this somewhere in the children, and things like this. So that is the formula part of the check, and then there is the message. In this case, it will be property, and then the declaration name is a pointer type marked with a assigned attribute. The suggestion will be use a different attribute, like strong or weak, and the severity would be warning. And the nice thing is you can just put all this in a file, and then just pass that to Infer. You don't need to actually change Infer for this to work, and then you have a check. So how you actually use Infer in the command line, I'm going to talk about it a bit later. But it will be something like this: Infer minus lintas def file, the file, and then dash dash, and then the build command. So now I would say a bit more about this unavailable API in iOS SDK check that we find very useful. So it warns about the use of an API, a constant or a method call, in a version higher than the supported version. So you need to pass to Infer what is the minimum version you want to support with this option, iPhone OS target SDK version. And so here's an example. So we annotate this method m with ns available version 10, and then when we call it, and we pass to Infer that we want to support version 8, it tells you the selected m is not available in the required iOS SDK version 8, only available from version 10 at this line, and this could cause crash. And then it also takes into account, like, if you wrap it in an if, like a respond to selector, or if the version is greater than blah, then it doesn't show there. Okay. So Infer is open source. It's been for about 2 years. This is how our website looks like. So we've had good activity in GitHub, about over 6,500 stars, various issues, a few external contributors, not too many. A few companies are using Infer already, other than Facebook and all the Facebook-related things like WhatsApp and Oculus and Instagram. There's also other companies like Spotify, Uber, and so on that are using it. So it is easy to use it. So we publish releases every couple of months, maybe. When one can download master directly from GitHub and install it. But we also have releases that we put in Brew, so you can just do Brew install Infer in the Mac. And there's also available via Docker. And so more information is in the website. So we have a few supported build systems like Xcode build, Make, Gradle, Bug. I've seen some more, Maven, and so a few. And then the command is infer-build command for analyzing the code that can be compiled with that command. And so this is the input, and then the output will be, so in the command line, there will be printed some number of bugs that it finds, like just up to like 10. And then in another file, there will be all the bugs, and then there's also a JSON report that can be then further processed in a CI. So there are many, many options for Infer to customize it in various ways. So one way is the analyzer. There is the interprocedural analyzer Infer, and then there is the linters. So you can say -a Infer or -a linters to have just that one analyzer, and by default you get both. So and the good thing is the linters is faster because it doesn't look at the whole code together. It's like file by file, so it does the analysis file by file in parallel, so it makes it faster. So some more detail about the integration. So with Xcode build, we use XCPretty to provide a compilation database that is a JSON standard from Clang that contains the file and the compilation arguments and the execution folder. And then So Infer computes the compilation database and then calls each of these Clang commands and connects with the Clang AST from there and continues. So I wanted to show you some concrete example of running Infer on some real-world app. So this is XKCD app. So it's about 130 files, 30,000 lines of code, and it took to analyze about 7 minutes in Mac Pro. And it found about 32 Infer issues and 26 linter issues. So some examples of things it found. Some of these parameters are not checked. About some block handler that was passed as a parameter to the method. And one of these strong delegate warnings of this property from type comic view controller delegate that in general shouldn't be strong. And so that's that. So we're always looking into adding more bug types and also improving the DSL so that it can be used very widely. And we're also looking into performance improvements because it's still not very fast, and it is important in the Facebook scale that we don't take too long. And so at the moment, the DSL only works for the Clang AST, but there is nothing very hard to make it more general to work with other ASTs. So we may look into that in the future, for example, to provide some first support for Swift and also for the Java AST. So this is where you can find Infer in GitHub, and the website is fbinfer.com. And that's it. Do you have questions?